Today in the physics lab, we're going to look at astigmatism. So with astigmatism, essentially your eyeball is shaped rotationally symmetrical. So first of all, I wanted to point out this chart here from the packet that came with the human eyeball model. And it kind of gives you a little test to show, test for astigmatism. So essentially, if you look at these lines, it says right here, cover one eye and look at the chart. Do some of the lines look darker than others? If they do, then you need to rotate the figure 90 degrees and convince yourself that the lines are actually the same, and it's just your eye causing the effect. So obviously, I'm not a doctor, but if you do notice an issue here and you don't know that you have astigmatism, you may want to have a doctor look at that. So this is just a neat little test chart, but how does that work? You know, what's going on in real life? So let's kind of dive in here. So here I've got the human eyeball model that we've been using. It's just our regular 62 millimeter lens. I've got my pupil in here, and I've got this thing set to the normal setting. And so we have our normal image at the back of the eyeball. It's upside down, it's reduced, and it's a real image. So to demonstrate astigmatism, well, our lens has to have astigmatism in it. So to do that, first of all, I'm going to take the pupil out, because it's kind of difficult to reach in there otherwise. So I'm going to take this lens, and if we look at this lens here, you'll notice that it has two little slits on it. Right? It's got one over here and one back on this side, and that indicates the axis of symmetry for this particular lens, because it's not, you know, spherically symmetrical. So I'm going to plop this in here to give our eye model some astigmatism. So right now it's basically in focus, and so I'm going to plop this guy in here, and you'll notice that that's a blurry mess now. Like here, if I just take that out, you know, it's hard to see. Let me see if I can add this pupil back a little bit. Yeah, it's just going to be in the way. So here you can see it, like that is a much wider area, like that is not in focus. But what's interesting here is if I move this, it actually changes the shape. So you can see that, like, just moving the side to side changes, that's, first of all, it's not in focus, but also it changes exactly where, you know, is it stretched out this way? Like this is more of a side to side stretching, whereas this is getting closer to being an up and down stretch. And that's the whole deal with astigmatism, is it doesn't have to be in one particular, you know, it's not like, oh, it's not focused up and down. It's whatever axis it happens to be on. So how do we fix that? Well, we just make a lens that is not, you know, rotationally symmetrical either. So I've got another lens here. You can see that it's got notches in it for the axis of symmetry. So just for reference, the lens that I put in here, this extra, so this is 62, that's our normal focal length, but I went ahead and added this negative 128 to give us some astigmatism here. So I'm going to have to use a bit of a converging lens to make this work. So this is plus 307 if you're interested in that sort of thing. And so I can plop this in here, and notice it doesn't just pull it together. Like I have to kind of rotate it a little bit to actually get it to focus. And if I move it, you know, let's say to the other side, you'll notice it still is a blurry mess. That's because we want both of these things to have the same axis of symmetry in order for it to actually focus. So notice that, like in this case, you can see the handles here. So the axis of symmetry for both of these is the same. And so notice that, like, even with my corrective lenses, if these axes of symmetry are not right, it doesn't give me a focus for my image there either. So when diagnosing astigmatism, doctors have to figure out not only A, you have astigmatism, but then B, like what direction that's in to figure out how to correct it. And that is astigmatism.